Okay. So we're going to start on 6.1, which is discrete random variables. Okay, so remind me, I forgot already, what does discrete mean? Who said it? I think somebody said it.
Set number.
You said whole numbers?
I said set number.
You see, yeah, so whole numbers. Whole numbers. Okay, and just remind me again, what is continuous? Fractions, decimals, everything else. I'm just going to put everything else. Okay, so if we're going to be talking about discrete random variables, we're going to be talking mainly about whole numbers today. Okay, so so that's the discrete part here. Then we'll talk about a random variable. A random variable is a numerical measure of a probability experiment. Okay? And it's typically denoted with a capital letter, such as, and you're going to see this, the probability that random variable x equals lowercase x. Okay, so this is your random variable, RV. This is a specific value, such as 3. Okay, so I know that notation is a little bit weird. Okay, so let's just do some quick examples here. I guess I can't write any lower on that or it's going to go off camera. So the number of A's in a stats class, would that be discrete or continuous?
Discrete.
Discrete. Okay. Your possible values would be
Continuous. Possible values for the scores, or
no, I'm just talking about the number of A's.
oh, number of A's.
So what would be the possible values for the number of A's?
0 to 30.
0. Oh, you remember the 0. Okay. That's my class, right? All right. No, I won't give 0 A's. At least I hope not. That has happened to me before, though. Okay. How about the number of cars at a McDonald's drive-through? Is that discrete or continuous? Discrete. How about the speed of a car?
Continuous.
Continuous, right? Okay. All right. So, so some rules. Rules for discrete random variables. What should the sum of the probabilities equal? It should equal 1. And the probabilities should all be between what values? 0 and 1. Okay? All right. So let's do an example. I'm going to use Excel, although I don't technically need to. Yeah, I'm going to use Excel. All right. So let's start sharing our screen here. Share. Okay. So let's say.
Can you pull it up on the board?
Oh, yeah, that would help, huh? All right, so let's say that you ask a basketball player to shoot 3 free throws. X represents the distribution. And he can make, what would be the sample size in this, or the sample space? Not sample size, the sample space. How many could he make? Can make 0, very good. So, and I'm going to use a lowercase x for that. 0, 1, 2, or 3, right? Can't make more than 3 out of 3 shots. Okay? All right, so if the x is the number of shots that he makes and then the probability of x, so you have him repeat this experiment a bunch of times. He can make 0, 1, 2, or 3. I'll center these. I think it always looks better centered. And let's say that he makes 0 shots, 0.01, makes 1 shot, 0.1, 0.38, and 0.51. Okay, so my first question is this a legitimate distribution?
What's the first? 0, 0.
What'd you say?
What's that? Sorry.
0.01, 0.1, 0.38, 0.51. Those are the probabilities. No? Why not? What are my rules? Sum of the probabilities should add up to 1, right? So I should see sum all of those adds up to 1. Mark off the first rule. Okay. How about the second rule? Are all my probabilities between 0 and 1? So is this a legitimate probability distribution? It is. Okay. Is it what kind of let's see, what kind of probabilities are these? Are these theoretical, empirical, personal? Empirical, right? We measured them, do this a bunch of times. Okay. All right. So now let's see here how good you guys are. Can you make a probability histogram? Oh, those are back. Just when you thought you could forget that, right? How would you do that? It must be Tanner's turn.
You just select all the data.
Select all the data. Insert.
And then select bar graph.
Bar graph here.
And then go.
The 2D bar graph, right? Okay, so what do you notice there? Is there a problem? You wanted me to go, well, I can go quick layout like you said. Does that look right? No, why not?
Show both sides.
It's measuring the X's and I don't want to measure the X. I don't want, yeah, I've got 2 colors for one thing, right? I only want 1 color. So what's the problem? And how do you fix it?
Fix it. You just put like a apostrophe.
Apostrophe in front of this one, right? Apostrophe, 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 and apostrophe. Okay, because it was graphing the X's, and I wanted that to be the X-axis, not the. Okay. All right, so we'll do that again. Tanner, you talk me through it again. Highlight your data. Insert. Bar graph. 2D. That looks better. And quick layout. Okay, so you're all studying with Tanner tonight, right? You forgot how to do your histogram. All right, what should I put down here? Number of shots made. What's this?
Percentage of shots.
All right, yeah, percentage, or you could also put probability. Okay. And this is probability of shots made out of 3. Okay. What do you think? Does that look like a normal distribution to you? Oh, I should turn off this light. Doesn't look normal. What does it look like? How would you describe this graph? Literally skewed left. Okay. All right. Now, all right. Let's talk about how would you calculate the mean. Okay. calculate the mean for a discrete random variable. Okay? So for a discrete random variable, mu, mu sub x, equals the sum of x times p of x. Okay? So if I'm doing that, all I need to do is I need to find my product here. So I'm going to take x times p of x. Okay? I'm going to copy that formula down. I'm going to find the sum.
Is that a big X and a little X, or just the same? That's the same, right?
That's a good question. On my formula, I got a little x, but yeah, it is a little x. You're right. They're both little x's. The big X is always going to be a discrete random variable. All right. So I will find the sum. Okay, now let's think about this before I press enter. Without knowing anything about this, what would you expect the mean to be between? Okay, between 0 and 3 for sure, or maybe between 2 and 3, right? Okay, so hopefully this is between 0 and 3, 2.39. Okay, now is it appropriate to say that my mean is a continuous number, even though this is discrete? This is yes. 2, 3. This says no. 4. You didn't raise your hand. Yeah, it's okay. So I always joke about, you know how it says that Americans have 2.3 children? We either have 2 or 3 or 0 or whatever. But yes, your mean can be a continuous number, that's fine. So you would expect this person to make 2.39 shots out of 3 on average. Okay? All right, so if we've talked about the mean, let's talk. So this is often referred to as the expected value. Okay, as I mentioned before, we would expect 2.39 out of 3 shots to be made. Let's talk about the standard deviation. Okay, so you don't have enough standard deviations formulas, right? I'm going to give you another one. Okay, that's why this class gets hard. It's like, oh, how many standard deviation formulas am I going to get? Probably about 7 or 8. We're on like 3 now, I think. Anyway, so your standard deviation is, well, they've got 2 formulas here. This is the one I like. Sigma squared of x equals the sum of x minus mu squared times the probability of x. That's the one I like. Or you could also do the sum, sigma squared equals the sum of x squared p of x minus mu squared. And I'm going to put brackets around this one because sometimes people don't. So actually, is that the standard deviation of the variance? Maybe I'll relabel that the variance. How would you find the standard deviation? Take the square root of 1, right? All right. Gosh, maybe I should have brought 2 of these today. All right, so let's do the standard deviation. So the standard deviation. So we can do this twice. I'll do it with the first formula here. Okay. Now I will give you these formulas for the test. Maybe for the quiz tomorrow. I haven't decided yet. So what would be the first thing you would do? Let's use the first equation. We'll do this twice just to make sure you can do it either way. How would you do this the first time? What would be the first thing you would do? Find the mu. We've already found the mu. We use 2.39. So we're going to do x minus mu, right? So we're going to do x minus mu. So this is going to be equals what? What's my x? 0 minus 2.39. Okay, do I need to F4 any of those?
Yeah.
Yes, which one? The second one, the mu. Okay. So I get negative 2.39. I will copy that down, get all those. And then what do? I'm going to square it. So I'm going to take this number, I'm going to raise it to the second power. Do I need to F4 that? No. Okay. All right, so I've done this piece here. What's the next thing that I do? Nope. Multiply it by the probability of x. So I'm going to take that square and I'm going to multiply it by the probability of x. So I'm going to take this number and I'm going to multiply it by this number. Do I need to F4 any of those? No. I'm going to copy that down. Okay. Then what do? Now I sum it. Okay. So if I sum that, I get 0.4979. What is that number? That's your variance. How do I find my standard deviation? Equals the square root of that number there. Okay? What'd you say?
What was
We're going to multiply by the probability of x. So basically, I take that whatever I squared. Okay? Now, let me ask you, does 0.7 seem like a reasonable number for your standard deviation? It's less than one shot, right? Yeah. Now, by the way, let me ask you another question. Could you draw the mean on here? Or where's the mean located? What? 2.39, right? So how would you draw it on here? What?
You just grab a line.
You just grab a line, insert, shape, line. So 2 is there. It's probably, that's probably about 2.5, right? So I'll say about right there. And then if I added some text here, like a text box, I could add mu equals 2.39. There you go. It's a way bigger box than I need, but that works. And maybe I'll make that black so you can see it better. Make it a black line. Okay. Piece of cake. All right. How about, do you want to do this again with the other formula? Just to see which one you like better. Okay, so we'll use the other formula. I should get exactly the same answer, hopefully. And I put brackets around here. You're going to need to remember that because I don't think those brackets are around your, they're not in your formula sheet. So I put it there because I think it makes it more clear. Okay, so what do we do first here? I need to find x squared, actually. X squared, okay? So that's going to be 0 squared, okay? Copy that down. Only need that one there. Okay, I like to center everything. Now, what's the next thing that I do according to this? Times the probability of x. So I'm going to take this number and I'll multiply it by that probability. Okay? I'm going to center it because I think it looks better. Okay, so I got a bunch of numbers there. What's the next thing that I do? I'm going to find the sum of this column, 6.21. What's the next thing I'm going to do? I'm going to subtract mu squared. Oh, whoops. Okay, so I'm going to take this number and I'm going to subtract that number squared. And that gives me 0.4979. That's a good sign, right? What is that number? That's the variance. And finally, I'm going to get, how do I get the standard deviation? Square root of my variance. Okay, so it works either way. Who likes formula number one?
Like formula
In the computer. Who likes formula number two? Okay, I don't care which one you use. Use the one you like better. Now, let me ask you a question. Do you think Excel can find this standard deviation?
Yes.
No. Okay, just to prove it, this is the correct answer. We've gotten it twice now. I don't care what formula you use. So you do that, whoops. STDEV of all this stuff. You ain't getting that answer, okay? So you can try, some of you will, don't do it. It's gonna be wrong. There's no way to get this. You gotta do it my way, okay? All right, gosh. I only brought one thing of notes today. Let me look here. Let's move on to 6.2. That was so easy.
Practice problem.
This will give you more time later on to slow down when we have easy, harder stuff. All right, so 6.2. Then we into 6.1. Okay, so this is good because we're going to talk about, maybe I'll go back to the board here for a minute. Okay. So 6.2 is binomial probability distribution. Okay. Now, here, I'm going to pull this up. It's going to make my life easier. All right, so a binomial probability distribution has only two options. Okay, number one. How many options did I have on the discrete random variable? 3. That's 4, right? 0, 1, 2, 3, and 4. That's 4. 0, 1, 2, and 3. That's 4. Okay. All right. So you could think of a coin flip. Only has two options, heads or tails. You could think of a true false. True false. Yes, no, etc., etc. Okay. So, so that's option number one. Option number two, we are assuming that all trials are independent. Okay. Number three, we're assuming that we're going to repeat the experiment a fixed number of times. And number four, probability of success, define that any way you want, is the same for each trial. It seems to be a repeat because 2 and 4 are basically the same thing. Yes?
What was number 3 again?
3 is you're going to repeat the experiment a fixed number of times. Okay? So as far as notation here, I guess I should move this over. One that I can't see. All right. As far as the notation goes, you can do n equals the independent trials. You're going to let P equal your probability of success. One of the things you're going to find here, for some reason, statisticians love the letter P. I like to say that Q equals your probability of failure, which with the complement rule is simply 1 minus P. And we're going to let capital X equal your random variable of X equals 0, 1, 2, etc. successes. Successes, which is going to be less than or equal to n. Okay? All right.
What is n again? Sorry.
N is your number of independent trials. I guess I should use this as lowercase n. Lowercase on both of those. Okay? So some examples of that, let's say a basketball player historically makes 80% of their free throws. Okay? Now, they either make it or they miss it, right? Does that mean that it's always 50%? No, if you get Steve Kerr at the line, or who's the coach now? He used to be a really good free throw shooter. Rick Barry, really old basketball player. Shaq, like 40%, okay? So what we're saying is it doesn't have to be 50-50, even though you've got two. It's not a coin flip, or you could think of it as a coin flip in the fact that 80% of the time he's going to make it, only 20% of the time he's going to come up tails. Okay? So it doesn't mean 50-50, but you do have two options, okay? So, all right, so let's say that, I'm going to start sharing here. Where's my Excel? Here, we're going to go here. Share. Okay, let's say that 7% of people have O negative blood, according to the Red Cross. Okay. So I want to take a sample of 4 people and count the number of O negative blood. Okay? All right, so what's my sample space? How many people out of 4 can have O negative blood? 0, 1, 2, 3, 4, 4, right? Okay, so we can think of this as a binomial probability where I'm going to call success equals O negative. Okay? I'll rewrite that. Success equals O negative. Okay, so if I've got, so another way to do my sample space, if I've got 0 people with O negative blood, what has happened? I've failed 4 times in a row, right? Okay. All right, so what's the probability that I get somebody that is not O negative blood on the first person? What's that? It's not 100%. 0.93, right? So the first person is 0.93. What's the probability that the second person also 0.93? Third person, 0.93. Fourth person, 0.93. Okay? So the probability that I get 4 failures in a row Oh, I did something wrong. Oh, I forgot my decimal. 0.74805. Okay. Now, how can I get one success and 3 failures? I could get a success, fail, 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 or fail, success, fail, fail, or fail, fail, success, fail, or fail, 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 success. You all agree with that? Okay. Now let's do the first option there, right? So the probability that I got a success on the first try is 0.07. Probability I got a failure on the second try, 0.93, right? Failure on the third try, 0.93. Failure on the fourth try, 0.93. Now, does the order really matter? Okay, but it could happen 4 different ways, right? So can you see that I could multiply that by 4? Because it doesn't really matter where I put the success in option 1, 2, 3, or 4, but there's 4 ways to get it, right? Okay, so that works out to be 0.22522. Now let's do the sample space for option number 2. Okay, I've got 2 successes and 2 failures, or success, failure, success, failure, or success, failure, failure, success, or failure, failure, success, success, or failure, success, failure, success, or failure, success, success, failure. Okay? All right, so let's do the first option. Probability of success on the first try. Is 0.07. Probability of success on the second try, 0.07. Probability of failure on the third try, 0.93. Probability of failure on the fourth try, 0.93. Does the order really matter?
No.
No, but how many ways can I do this? 6 ways. 6 ways to do this, right? Okay, option number 3, I'm going to get 3 successes and a failure, or success, success, failure, success, or success, failure, success, success, or failure, success, success, success. Okay? First way is success is 0.07 times 0.07 times 0.07, and then a failure 0.93. How many ways are there to do this? There's 4 ways to do this. Okay. Finally, success, 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 right? There's only one way that happens. Okay. So that's going to be 0.07 times 0.07 times 0.07 times 0.07. Only one way to do it. That's all we get. Okay. Is this a legitimate probability distribution? How do you know? You add them up, and what should it add up to? 1. Do you think it's going to add up to 1? Yes. Okay. Now, if I had more than 4, this would suck, right? Who wants to write out all those sample spaces? It's going to suck. So here, I got a better formula for you, okay, instead of writing all that out. So the formula is, this is for the binomial probability distribution. Okay. Binomial. Okay, it's going to be the probability of x equals the combination of n choose x. Now you know why we just did chapter 5.5, right? Because we're doing combinations. P to the x, q to the n minus x. Okay. So, guess what? There is actually a binomial distribution formula. Okay. You can use it on Excel. You can't use it on the quiz tomorrow, though. But watch this. I can use binom dist. Now, there's two of them. These are exactly the same, whether you use the one with the dot or the one out, it doesn't matter. Okay. Number of successes. If I want 0 successes, number of trials is 4. Probability of success is 0.07. Do I want cumulative? Okay. This is where it gets a little tricky. Maybe I should save this for tomorrow, because I know we're rushing here. False. Sometimes you're going to put true. I'll save that for tomorrow. But what I do want to show you is, look at that. I got the exact same answer. Okay. And in fact, if I had, instead of put this 0 here, if I'd have done this here, like that, you'll see that all of those are exactly the same. Okay? All right, so the quiz tomorrow will be on, we didn't finish 6.2. I thought we'd get farther along than we did. 6.1 for sure, maybe 6.2, we'll see.
Well, we don't need to know.
At least what I showed you in class today. Okay? All right, see y'all tomorrow.
Are you ready for the quiz tomorrow? Okay.